So let's continue with our lesson on combinations and permutations. But remember where we ended last. We ended where we created or we derived the formula for permutations and combinations, right? So let us have examples and see where we are going to use this. I'm sure everybody's worried, but where am I going to use this? Okay? In our first question, how many different ways can you arrange 3 books on a shelf from a group of 7? Okay? So there, the main word we are looking at is arrange. So if we're saying arrange, so that means we're talking permutation, because arrangement matters. And this one, it doesn't really matter, okay? So we're going to say how many, what's the total that we have? We have a total of 7, and we're picking only 3, so let's use the formula. So there, using the formula, you say 7 factorial divided by 7 minus 3 factorial. That will be 7 factorial, 4 factorial. That will be the same as 7 times 6 times 5 times 4. Here, I'll leave it as 4 factorial because I have 4 factorial there. So I'm going to, okay, multiply, and 30 multiplied by 7 is 210. So 210 possibilities, okay? So let's look at the second question. The second question says, how many different ways can you arrange 5 books in a shelf? But am I choosing anything? No, I want you to arrange all 5. If I want you to arrange all 5, so that would mean I have 5, and I want to pick 5, right? So that would be 5 factorial divided by 5 minus 5 factorial, 5 factorial divided by 0 factorial. And remember what we said 0 factorial was? 1. So that will be 5 factorial divided by 1. So that will be 5 times 4 times 3 times 2 times 1. So that will be 20. 20 by 6 is 120. All right? And then the third one that we have is how many teams of 4 can be produced from a team of 12 engineers. We have 12 engineers, and we want to only produce teams of 4. The question you want to ask, does the order really matter? Here, the order doesn't matter. You just want the groups of 4. So if the order does not matter, we use combinations, right? Let's look at question 3. Question 3 says, how many teams of 4 can be produced from a team of 12 engineers? So the total that you have is 12 engineers. But the question we had to ask first is, does the order really matter? The order doesn't matter. You just want 4, 4, 4, right? So the order doesn't matter. And if the order does not matter, we use combinations. So that will be 12, choose 4. So that will be 12 factorial using the formula. 12 minus 4 factorial multiplied by 4 factorial. So that will be 12 factorial. This would be 8 factorial multiplied by 4 factorial. You don't multiply 8 times 4. No, you don't do that. Okay? So that will be 12 times what? Times 11, times 10, times 9, times 8 factorial. Why am I saying 8 factorial? Because I want it to cancel with that. So you're going to have 8 factorial times 4 times 3 times 2 times 1. So this is going to cancel with that. So there you are going to have 4 times 3 is 12. That is going to cancel with that. So you are left with 2 there, and that is 5. So that will be 11 times 5 times 9. And the answer that you get will be your combinations. Let's go to the second question. The other question says, now this is a bit different. This is a bit different. Think about it. How many different ways can you arrange the letters in the word Alabama? So you have Alabama. So here you're asking yourself, Mister, what am I going to use, right? So here we're going to use the counting principle. The counting principle, you'll say, how many letters do I have? 1, 2, 3, 4, 5, 6, 7 letters. So you have 7 factorial, right? But how many letters are repeating there? Alabama. How many letters are repeating? You've got 4 letters that are repeating, right? So you have to eliminate them. So you are going to say divided by 4 factorial. Okay? So 7 times 6 times 5 times 4 factorial, 4 factorial. You cancel out, and then you'll have 30 by 7, which is 210 there. Okay? And then I want you now to do the questions that I have on the board. I'll give you just 1 minute to do the questions on the board. I'm counting. Okay, now time is up. All right, let's look at it. This question 5, it has Mississippi. It's the same question like the last one. So you say, we're going to use the counting principles, but then we are going to divide by all the repeating ones. So here we have 11 factorial, but then we've got 4 S's, so we are going to divide by 4 factorial, but also we have how many I's? 1, 2, 3, 4. 4 factorial again, because you want to delete all the ones that are repeating. You don't want to, okay. All right, and you've got 2 P's. So you've got 2 factorial. So what will that be? So that will be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. And here, I'm going to leave this 4 factorial to cancel with that one. And that will be times 3 times 2 times 1 times 2. Okay, times 1, right? So here, that is going to cancel out with that. But then we have 4 and 2, we make 8, so they're going to cancel out with that. And 3 and 2, they cancel out with that. So we're only left with the numbers on top. So that will be 11 times 10 times 9 times 7 times 5. And I'll leave you to just calculate that and find the answer, okay? All right. And the next one, this one, I'm not going to do it for you because I want you to do it on your own, okay? How many different ways can we arrange letters in the word Russia, all right? Now, use the counting principle to do that one, okay? So let's proceed to the next question that we have here, because now we want to choose. The others are almost the same as the one I did, but then I did them for you. We're going to be doing it together in this case, okay? All right. You've got 10 racing dogs. And how many different ways can the first 3 places finish? You say 3 places. So you've got the first place, the second place, and the third place. The question that you ask yourself, does order matter? Do I have to put them in any order? I would say yes. Because if you have your number 1, you cannot have the first position taking the second position and the third position. So the order really does matter. So in this case, so that will be 10p3. Then when you have 10p3, using the formula, that would be 10 factorial divided by 10 minus 3 factorial. That would be 10 divided by 7 factorial, and that's going to give you 720 ways. Okay? And let's look at question 7, and I think you will love question 7. Question 7 says 15 people running for vice president and president of Uzbekistan. So you've got 15 people, right? And you want to choose president and vice president. The first question is, does the order matter? Does the order matter? I would say, what do you think? Does the order matter? Yes, it does, because once you choose the president, you're not going to have the president again standing for the vice president. You're going to choose the president once, all right? So since it is permutation, we're going to use permutation formula, which is 15, pick only 2, and then that will be the formula, and 15 divided by 13, that will be 210 ways, all right? And then what if you are given, you're doing probability, and they say calculate 8C5? You know that you're talking about combination. So you're just going to use the combinations formula. And that's the formula we have. The one that we have there has R, but it doesn't really matter. It's a variable. Ours, we had K. It doesn't really matter. This can be M, X, whatever, right? So that's what we have. So we have 56 ways. So in question 7, how many ways to choose 5 people out of 30 to put in a group? You want only 5 people, right, to put in a group. And the total is what? The total is 30. And the question you have to ask yourself is, does the order really matter? What do you think? I don't think the order matters, because you just need 5 people in a group, right? So in that case, you're just going to choose combinations. And when you work it out, it's going to be that value there, all right? And this is mainly for women because they like carrying, many clothes, right? When they go for vacations and that. So you have 10 pairs of shoes, 10 pairs of shoes, 7 pairs of jeans, and 5 pairs of shirts. How many possible outfits can you get from this, right? So you cannot wear 10 pairs at the same time. So you have to, from 10, you choose 1. From 10, you choose 1. And from 7 pairs of jeans, you choose 1. And then from 5 pairs of shirts, you choose 1. And what will you have? You just multiply those possibilities, and you are going to have 350 outfits. So you see, there is no need for you to take loads and lots of clothes. You can just take this, and you go to your holiday. And from that, you will have 350 outfits. Okay, this will be the end of our lesson, and I hope you guys enjoyed our lesson on permutations and combinations. It was great having you. Bye for now.